Hey everybody, in this video we are looking at example 46 on our pre-calc final exam review playlist. We are given f of x, g of x, and h of x. I already made a few disclaimers about f of x, so if you are a little annoyed that there's no information describing f of x as being a restricted domain so that it's one-to-one, so that we have an inverse, go back to that one, number 45, and look at that one there. I was just being nitpicky about the way the question was written, and I just pulled this question from a separate source, so you know, I'm just being a pain. But this question is asking us about f of g of x. Hopefully everyone remembers what that is called. This is called composition of functions. It's where you put one inside of another. Even think like of a composition of music, or you write a composition essay, like you're putting a bunch of different ideas within each other, musical instruments playing one within the other ones playing, they're all playing together to make a giant composition. The composer is the one who puts them together. So composition of functions in math is us putting functions together, one within another one, to create a new special type of function. So that's what that is. Here we have the question asking us to find f of g of x. So that means f is our mama kangaroo and g of x is our Joey going inside the pouch. Where's the pouch? Everywhere x is. Or like you think of it like you have a roommate, now they're your ex roommate, right? You kick them out, and everywhere x lived, like x had a certain parking spot, certain bedroom, certain whatever, now that belongs to g of x. That function is going to move in over there. So the left side of the equal sign, I'm going to really stress this in this example, because I find that a lot of people are pretty lousy at writing both sides of the equation, and I think it's really beneficial for people and their understanding. So x, oh no, where'd you go? Sorry. X squared, that's really ugly too, squared plus 3 all over 5. Now the left side, what am I dealing with over here? I'm going to kind of specify a little bit with the highlighter. So g of x, right over there, is the left side. So let's even use the purple, okay? G of x with purple, I'm putting that on the left side of my equal sign. It went in place of x. It went right in there, okay? Right in there. Then let's switch to a reddish highlighter. The right side of my equal sign is going to go on the right side of the equation. It's going to go right in there, or where x is, so right in here, okay? That goes there. So g of x went in for x on the left, where f of x was, and then what g of x is equal to, square root of 5x minus 3, goes in on the right. Okay, you seeing that? So that's going to go and get plugged in there. I think, like, even if you're like, yeah, whatever, I do that, but like think about it a little bit more, because writing your own formulas for making your own, spreadsheet to do certain things. I even had that grade predictor I gave you guys, very simple formulas in there. All that stuff, it goes into like different types of coding and programming, and who knows what job you're going to have in the future. So really understand how equation relationships work and how you could plug one equation or function command, whatever, into another one, okay, to build a new feature, a new exercise, right? So I'm going to fill this in. So what will I get? Let's go ahead. I'm going to fill in the g of x. So I'll use the pink. So it's the square root of 5x minus 3. Now, sometimes that's all you can do. You can plug it in and you can't really clean it up. But in this case, it does appear that I can clean it up. So I have the f of g of x, that composition. If you square with square root, those are inverses of each other. They basically undo one another. So if I square something that has a square root, it's being multiplied by itself. It gets rid of that square root. Also, please don't forget that the square root is the same, like say of x, is the same as x raised to the 1/2 power. That being said, if I have x to the 1/2 power and I square it, according to properties of exponents, we multiply our exponents. And what's 1/2 times 2, which is 2 over 1, 2 over 2, or 1. And x to the 1 is x. So it gets rid of everything. Okay? Anyhow, let's continue. I have just 5x minus 3 next to it, plus 3. So just to kind of stress, that's where that came from. Keep track of what you're doing, right? All over 5. What happens next? In the numerator, negative 3 and positive 3, or minus 3 and plus 3 really, cancel. They made 0. Cancel means to make 0. So that's gone. What is left over? F of g of x, technically in the next step, is 5x over 5. Now, again, what can I do? Now, don't use the word cancel. We reduce, and what's left is, oh no, I forgot a parenthesis. How rude of me. There we go. And what is left is my final answer. F of g of x is equal to x. And that is it. Now that would appear to me that we probably have functions that are inverses of each other. Again, it goes alongside with a restricted domain in some way. Like if this is restricted domain, right, where x is greater than or equal to 0, then they are truly inverses of each other. As written, without any other disclaimer, they actually aren't inverses. If this is just the quadratic function, right, this graph is a parabola like that on the xy plane. Okay, and the pink is really just that, and those are not, oh, you can't see, sorry, those are not, maybe I could draw it better for you to really demonstrate. And you're probably like, why is she so passionate about this? Like, enough, lady, what are you blabbing about? But the pink is vertical compression 1/5, so it's a little wider and flatter. All right, and shifted up whatever I said it was before. What did we say it was? 3/5. So there we go. That's the parabola as written. And then the square root as written. The way I like to write it with you guys is I usually would factor out that 5 in a way. So that's 5 quantity x minus 3/5, close like that. So that's to the right 3/5, and that 5 is in the backward house. So that is a horizontal actual compression, not stretch, of 1/5, the reciprocal backward house, right? So that means over the same amount that the other one moved up. Oh yeah, this one was yellow actually. So it's over 3/5, just like the other one was up 3/5. And instead of it being classic shape, it had a compression. So I actually curved it more like that. And then the identity function is in here. So it's not, it's only giving me a reflection of that as written. And it's making me crazy and I can't stop thinking about it, but it's not important right now. So whatever, you could have fast forwarded, maybe you're not even watching anymore. If you are watching, wow, you're such a super student. I'm so impressed with you. But that should be the final answer, with f of g of x equaling x and only x. Please watch for any opportunity to distribute a negative. That is where people stink it up the most. Love it. Thumbs up. Not so much. Thumbs down. Comment, question, concern, feedback, request. Go ahead. I do have a playlist on function stuff. I don't know if it's specifically composition, but I will try to tag that or put it on the screen right now at the end. If I do have that, check the description box or one of the playlists for more of the content you are searching for. That's it for now. Adios. Sorry, this one was longer than the past bunch of videos. Unnecessary, I know. Bye.